Hello my students. So in today's video I am going to cover fractions. So this video is divided into 4 sections. We have the subtraction and addition of fractions, as well as multiplication and division. So I'm going to start off with the first two, which is subtraction and addition of fractions. What I want you to take note of is that whenever we are adding or subtracting fractions, we need to make sure that the denominators are always the same. Right, as you can see over here, our denominators are the same. You can see in all cases over here. Okay, that's good. So the denominators are the same. And since the denominators are the same, we can just go ahead and sum up all of the numerators while keeping the denominator the same. So 1 plus 2, that will give us 3. Okay, here we have subtraction over here, so this will be 3 minus 2. That will give us 1. 7 plus 1, that will give us 8 over 13. We have 6 minus 5, that will give us 1 over 9. And we have 2 minus 1, that will give us 1 over 3. Okay, that's quite simple. So now, what do we do in a case where the denominators are not the same? Okay, we're going to make sure that the denominators are the same before we can add or subtract them. So in order to manipulate these fractions into having the same denominator, we're going to check to see what is the lowest common multiple that both denominators can fit into. So by lowest common multiple, I mean if I were to multiply 3 a certain number of times and 5 a certain number of times, what is the lowest common value or multiple that they will eventually share? Right? So for example, if I take 3 over here and I multiply 3 by 1, that will give me 3. If I multiply 3 by 2, that will give me 6, 9, 12, 15, and 18, and dot, dot, dot. If I must take 5, 5 times 1, that will give me 5. 5 times 2, that will give me 10. We have 15, we have 20, and dot, dot, dot. So in this case over here, since they both share the value of 15, 15 will be my lowest common multiple. So if I look back over to this question over here, how many times do I need to multiply 3 in order to get 15? Well, I need to obviously multiply by 5. And whatever I multiply with the denominator, I multiply with the numerator as well. And then for this over here, for this fraction over here, how many times do I need to multiply 5 to get 15? We know we just have to multiply by 3. And we do the same with the numerator as well. So if I were to rewrite this entire question over here, 1 times 5, that will give me 5. And 3 times 5 will give me 15. Plus, remember, keep the sign the same. 2 times 3, that will give me 6. And 5 times 3, that will give me 15. Okay, cool. Now we know our denominators are the same. We can actually just go ahead and sum up the numerators. So 5 plus 6, that will give me 11. Yeah, and that's pretty much the answer. Okay, let's look at another question. 3 over 4 minus 1 over 6. Okay, if I were to look at the multiples of 4 and 6. So I have 4 8, 12, 16, 20. So we have 6, so we have 6, 12. Okay, here we go. I can actually see that the lowest common multiple will be 12. Therefore, if I were to rewrite this, so 4 times what will give me 12, that will be 3. And 6 times what will give me 12, that will be 2. Okay, so if I rewrite this now, this will give me 9 over 12 minus 2 over 12. Since the denominators are the same, I can go ahead and just subtract the numerators. So 9 minus 2, that will give me 7 over 12. Let's look at another one. We have 1 over 4 plus 3 over 7. Okay, here I already have the multiples of 4. I'll just go ahead and find the multiples of 7. So we have 7, 14, 21, 28. Okay, let's see if we just find more multiples of 4. So we have 24 and 28. Okay, cool. There we have this one and this one being my LCM. So 4 times what will give me 28. 4 times 1, 2, 3, 4, 5, 6, 7. So 4 times 7. And 7 times 1, 2, 3, 4. Okay, let's rewrite this. So 1 times 7 will give me 7. And 4 times 7 will give me 28. Okay, so 3 times 4 will give me 12. And 7 times 4 will give me 28. Okay, you can see the denominators are now the same. Let's just go ahead and sum up the numerators. So 12 plus 7, that will give me 19. Let's have a look at another one. We have 1 over 4 plus 1 over 2. Okay, this one is quite simple. We have the multiples of 4. Let's look at 2. So we'll have 2, 4. Right? I can actually just stop right here because, yeah, the lowest common multiple is 4. Okay, so I can just multiply this by 2 and this by 2. So if I were to rewrite this, we'll have 2 over 4. So 4 plus, oh wait, sorry. The denominators remain the same. And let's just go ahead and add the numerators. Cool. Let's just look at 2 more of these kind of questions. 2 over 3 minus 1 over 6. Okay, also another very simple one. We have 3. So 3, 6, 9. And can you just look at that? Okay, so 3 times what will give me 6? We know that is 2. And yeah, 6 is basically just 1. So it does not really change anything over here. So rewrite this. So 2 times 2 will give us 4 over 6. And 1 over 6. Denominators remain the same. And let's just subtract the numerators. So 4 minus 1, that will give us 3. Okay. You could go ahead and further simplify this. So 3 over 6 is the same as saying 1 over 2. And why is that? If I divide both denominator and numerator by 3, 3 divided by 3 we know it's 1, and then 6 divided by 3 is 2. So you could say that this is an answer as well. That's just simplifying this over here. And if we look at 3 over 4 minus 2 over 9, and I've given myself a problem because I can already see that this is going to be a very big LCM. But let's go ahead and just find all the multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, and 36. And let's look at 9. So we have 9, 18, 27, and 36. Okay, that was actually much quicker than I thought. Right, we can see that both share 36, so we can say that the LCM is 36. So what did I have to multiply 4 with in order to get 36? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's times 9. And then for 9, we have to multiply 9 with 1, 2, 3, 4 to get 36. So if I'm going to just rewrite this, so 3 times 9 will give us 27 over 36 minus 2 times 4 will give us 8 over 36. Denominators remain the same. 27 minus 8, that will give us 19. Okay, cool. Okay, and just a few more questions under the topic of subtraction and addition of fractions is I want to deal with improper fraction. Let's say I have 1 with 3 over 4 plus 2 over 3. And I'm not sure if you can remember is that whenever we have a mixed number like this over here, it's the same as adding. It's the same as saying, adding 4 over 4. Right? Because this 1 over here, it represents a whole number, or you could think of it as a complete fraction. So you're going to add this amount of complete fractions, right, with this fraction over here. Right? We're going to look at more examples so you can see it from a different perspective. So just remember, whenever you see a whole number like this, you're going to basically add whatever the value of the denominator is. And yeah, so basically this whole number over here, we're going to multiply this with the value of the denominator. So we have 3 plus 1 times 4, that will give us 4 over 4. And then 3 plus 4, that will give us 7 over 4. So let's have a look at another one. So let's say we have 2 with 3 over 4. So I will then say 2 times 4, right, over 4, right? Remember this value over here, we multiply with the value of the denominator. And make sure you're always doing it on the numerator side of the fraction. So 3 plus, so 2 times 4 will give us 8. And 3 plus 8 will give us 11. 11 over 4. Let's have another look at a similar question. Let's say we have 3 with 3 over 4. So I'm going to say 3 plus 3, times the value of the denominator, which is 4. So we have 3 plus 3 times 4 will give us 12 over 4, and 3 plus 12 will give us 15 over. Okay, so I hope you understand now how we can convert these mixed numbers to an improper fraction, right? An improper fraction is when you see that the numerator is much larger than the denominator. Okay, so if I were to rewrite this mixed number over here into an improper fraction, we already worked it out to be 7 over 4. Okay, and plus 2 over 3. And you can see over here, in this section over here, the denominators are not the same. So let's have a look at the lowest common multiple. So 4, 8, 12, right? And 3, 6, 9, 12. So the lowest common multiple over here will therefore be 12. So 4 times what will give me 12? 3. And 3 times what will give me 12? 4. Okay, so we know that the denominator should be 12. 7 times 3 will give me 7, 14, 21. Plus 2 times 4 will give me 8. So now that we see that denominators are now the same, let's just go ahead and sum up the numerators. So 21 plus 8, that will give us 29. Okay, cool. Okay, let's have a look at this one over here. So we have 1 and 2 over 9 plus 1 over 8. Okay, let's just go ahead and try to find what this mixed number is. So we have 1 with 2 over 9. So we have 2 plus 1, right? This whole number over here times the value of the denominator over 9. So we have 2 plus 1 times 9 will give us 9. 2 plus 9, that will give us 11 over 9. Okay, cool. So this mixed number over here, we converted it to its improper fraction, which is 11 over 9. So 11 over 9 plus 1 over 8. Okay, we can see that the denominators are not the same. So what does that mean, ladies and gents? That means we need to now find the lowest common multiple. Okay, so this is just a quick hack, right? Instead of having to now write down each and every multiple and trying to see what value is the same, you can just go ahead and multiply this side by the denominator of this side over here, which is 8. So you can do that like that. And for this one over here, I'm going to do the same. Multiply this side with the denominator of this fraction over here. So it's times 9. So 9 times 8, we know that will give us 72. And 11 times 8 is 88. And 1 times 9 will give us 9. And 8 times 9, we know it's 72. Denominators remain the same. And 88 plus 9 is 97. And we could leave our answer like this. There is no problem in leaving your answer as an improper fraction, right? Remember, improper fraction is when the numerator is larger than the denominator, right? We can clearly see that over here. So we could leave our answer like that, or we could rewrite this into a mixed number over here, right? So the easiest way to do that is ask yourself, how many times can 72 go into 97? Right? We can clearly see it can only go in once. So I'm going to place a 1 over there, right, as my whole number. So I have 1, and we know that the denominator must remain the same. But now, what is the numerator going to be? Right? It's quite simple. All you can do is say 97 minus the denominator, which is 72. Okay, 25. Another way of writing the solution. Either way, still 100%. Okay, let's just have a look at one more to try and cement everything that we have just learned. So we have 1 with 4 over 9 plus 2 with 3 over 5. Okay, let's have a look at 1 with 4 over 9. Okay, so I can say 4 plus 1 times the denominator, 4 plus 9, will give us 13 over 9. Okay, let me go ahead and write this mixed number over here into its improper fraction. Okay, let's have a look at 2 with 3 over 5. So I'll have 3 plus 2 times the denominator's value over 5. 3 plus 2 times 5 is 10. Okay, and 3 plus 10, that will give us 13 over 5. Okay, cool. So we have 13 over 5. The denominators are not the same, but remember that trick that I taught you. Just multiply this fraction over here by this denominator over here, which is 5. And do the same for this one as well. It will be 9. Okay, 13 times 5, value of 65, and 9 times 5, you know, that will give us 45. 13 times 9, that is 117 over 45. Yeah, let's go. The denominators are the same. Okay, let's go ahead and add 65 with 117. That will give us an answer of 182. Right? And if I were to convert this to its improper fraction, ask yourself how many times can 45 go into 182? So we have 45, we have 90, we have 135. Okay, we go one more, and we have 180. We can see if we go higher than this will give us 225. You can see that if we do go higher than 180, we'll get more than what the numerator is. So we are only going to stop until here. And how many multiples do we have? We have 4. Right, so I know that my whole number for this over here will be 4. My denominator remains the same. And what will my remaining numerators be? We know if we stopped at 180, and this value over here is 182, right? 182. So that means the only difference between these two will be 2. And that is another way of writing down the solution. Okay, so that is everything for the addition and subtraction of fractions. Let's go ahead and look at the multiplication of fractions. So multiplying fractions are pretty cool because there's no need to manipulate anything. Right? By manipulating, I mean having to make sure that the denominators are the same. Right? That's pretty much of a headache already. So multiplication, pretty much straightforward. We have a fraction multiplied by another fraction. Right? 2 over 5. All we have to do is make sure that we multiply denominator with denominator. That will give us 20. And then multiply numerator with numerator. That will give us 6. And that's pretty much a solution. We could go ahead and further simplify 6 over 20 by dividing both sides by 2. And 6 divided by 2, that will give us 3, and 20 divided by 2, that will give us 10. Alright, so that's another way of writing the solution. It's just simplified. Okay, let's have a look at this one over here. Times 2 over 7. Let us first convert this to an improper fraction. So 2 plus 1 times 3, 3. 2 plus 1 times 3, that will give us 3. And we have 5 over 3. Right, so let's rewrite this entire equation over here. Okay, cool. So now let's multiply them. Denominator with denominator. 3 times 7 will give us 7, 14, 21. And 5 times 2, which are the numerators, what will that give us? That will give us 10. Can I further simplify them? No, I cannot. Because we have an odd number and an even number, so we cannot simplify them. Okay, let's have a look at 1 over 5 times 1 over 4. Let's have a look at 3 over 11 times 1 over 3 with 2 times 3 over 8. Okay, we have 4 times 2 over 7. Right, so you can go ahead and pause the video and tackle these questions. Okay, so now let's solve them. We know denominator times denominator. So 5 times 4 give us 20, and 1 times 1 is 1. Okay, 11 times 3 will give us 33, and 3 times 1 will give us 3. Okay, cool. I can actually further simplify this. I can divide both numerator and denominator by 3, and that should give us an answer of 1 over 11. Okay, here we have the mixed number over here. So we have 1 plus 2 over 2. 2 times 2 is 4. And 1 plus 4 is 5 over 2. We have 5 over 2 times 3 over 8. Okay, remember, multiply denominator with denominator. So 2 times 8 will give us 16. And 5 times 3 will give us 15. Can we further simplify them? No, we cannot. Okay, so now we're having 2 mixed numbers. That is not an issue because we already know how to convert them. So 3 plus 1 times the value of the denominator. So 3 plus 4 over 4. This will be 7 over 4. Okay, this is for that over there. Okay, so we have 2 plus 2, alright, this value over here, times the denominator. And okay, all over 7. So we have 2 plus 2 times 7 is 14 over 7, and 2 plus 4, that will give us 16 over 7. Okay, let's go ahead and write these values over here. So we have 7 over 4 times 16 over 7. Okay, so 4 times 7 give us 28. But for this part over here, 7 times 16, that will give us 112. Can we simplify this? I can see they're both even numbers, so they should be able to be simplified. Let's have a look at the multiples of 28. So we have 28. We have 56. We have 84. And we have 112. Would you just look at that? Right, so 28 fits perfectly into 112. Right? How many times does it fit into 112? We know it's 1, 2, 3, 4. And therefore, this answer is 4. Let's have a look at dividing a fraction. Division is pretty much similar to multiplication, but we're going to do is multiply the first fraction by the reciprocal of the second fraction. So what do I mean by this? So we have 2 over 5, right? Divided by 2 over 3. I said we're going to multiply the first fraction by the reciprocal of the second fraction. So reciprocal, basically what it means. Say you have 2 over 3. I'm going to just take this fraction over here as an example. The reciprocal would be 3 over 2. If we have 5 over 6, the reciprocal would be 6 over 5. say we have 7 over 2, the reciprocal would be 2 over 7. Right, so basically all we're doing is we're just flipping the fraction. And remember I said we're going to keep the first fraction as is, 2 over 5, but we're now going to change this division sign over here, right, into multiplication. And if I do that, I need to multiply it with the reciprocal of the second fraction. So the reciprocal of this one over here will give us 3 over 2. Right? And we can go ahead and just multiply denominators. Remember, the denominators does not have to be the same. Just make sure you multiply them. Right? So 5 times 2 will give us 10. And 2 times 3 will give us 6. We can further simplify this, divide both sides by 2, and that will give us 3 over 5. That's that answer. Okay, let's have a look at another example. We have 1 over 2 divided by 5 over 8. Remember, keep the first fraction the same, 1 over 2, multiplied by the reciprocal of the second fraction. So this will be 8 over 5. Right? I just need you to see how I'm flipping this over here. Right? So whenever we have division, we're going to flip the second fraction. Right? And make sure you change the division to a multiplication. Please, please. Don't forget that. So we're going to change this to multiplication and we're going to multiply it by the reciprocal of the second fraction. So let's go ahead and multiply the denominators. That will give us 10 and 1 times 8 will give us 8. I can further simplify this by dividing both sides by 2. So that will give us 4 over 5. Okay, cool. Let's have a look at another example. We have 1 over 6 divided by 2 over 9. Keep the first fraction the same, times the reciprocal, which is 9 over 2. So 6 times 2 will give us 12, and 1 times 9 will give us 9. And can we further simplify this? Yes, we can. Divide both sides by 3. So 9 divided by 3, that will give us 3, and 12 divided by 3, that will give us 4. Cool. Let's try and tackle one that involves a mixed number. So we have 3 over 4 divided by 2 with 1 over 5. So let's just find the improper fraction for this. So 1 plus 2 times 5 over 5. 1 plus 2 times 5 is 10. And 1 plus 10 is 11 over 5. Okay, let's go. We have this part over here. Right, 2. So keep the first fraction the same and change this to multiplication and find the reciprocal of that, which we know is 5 over 11. So 4 times 11 will give us 44, and 3 times 5 will give us 15. Yeah, cannot further simplify that. So that's that solution. Okay, just 2 more examples, and that basically sums up everything for fractions. Okay, I know this is going to remain the same, but let's have a look at this. 2 there, 7 over there, 7, 2 plus 2 times 7 is 14 over 7, and we have 16 over 7. Right, so divided by 16 over 7. Oops, why did I put 17 there? It's supposed to be 7. Okay, remember, keep the first fraction the same, change that to multiplication, and the reciprocal of this will give us 7 over 16. So 5 times 16, that will give us 80. And 2 times 7, that will give us 14. Can I further simplify this? Yes. Divide both sides by 2. So 14 divided by 2, we know that will give us 7, and 80 divided by 2 will give us 40. So yeah, and just one more. Uh, 1 plus 1 times 2, and yeah, so 1 plus 1 times 2 will give us 2. 1 plus 2 is 3 over 2. Okay, so let me just rewrite this over here. Okay, let's change this to multiplication and the reciprocal. It's 3. Okay, so 7 times 3, 7, 14, 21. And 3 times 2 is 6. Okay, can I simplify this? Surprisingly, you can divide both sides by 3, you know. And this will be 2 over 7. Okay, so that basically sums up everything for fractions you are required to know for grade 8 up until university. You should know this off by heart. Everything you need to know about fractions, right? All the basic addition, subtraction, multiplication, and division of fractions. So I hope this video helped. Please leave a like and subscribe. Anyways, goodbye guys.